Alright guys, on this video I'm going to show you or try to explain what theoretical yield means in terms of the recipe that I've been using, or a very similar recipe that I've been using excuse me, for the previous videos. Okay, so let's take the recipe which we're kind of familiar with, right? 2 cups of flour, 3 eggs, 1 teaspoon of oil makes 4 waffles. Of course, if you have a different recipe into making waffles, well, you can stick to your recipe, right? So the question is, if I have all of these different quantities of my reagents, I have 5 cups. I have 5 cups of flour. I have 9 eggs. I have 3 teaspoons of oil. And what is my theoretical yield? What is the theoretical yield? This is the most waffles I can make before I run out of one ingredient. Okay, so we're going to be doing the same thing, dimensional analysis, mole to mole conversions on this case, but you will have to make a decision at the end, right? The most waffles that you can make before you run out of one ingredient. So what you have to do is, with 5 cups of flour, how many waffles can you make, right? With 9 eggs, then in a separate example, right? With 9 eggs, how many waffles can you make? And in a third example, or in a third dimensional analysis, 3 teaspoons of oil, you can make how many waffles with that. Okay, so let's start doing those conversions. Let's start with the cups of flour, right? So how many cups of flour do I have right now? It looks like I have 5 cups. 5 cups of flour. And I'm doing the dimensional analysis. So what are the two numbers, or what is my conversion that I'm doing here? I'm gonna write it, even though we're not using chemicals. We're doing a moles of A to moles of B conversion, right? All of those numbers are moles. If they're not given in grams or pounds or any of the common mass units, then those have to be moles, okay? So you're talking about pancakes and waffles. I think there's an example about resistors or bicycles. All of this you can think about quantities like moles, okay? So let's do a mole A to mole B conversion on this example. So I'm going to convert from cups of flour to waffles. And what are the numbers that I'm going to place in here? The stoichiometrical coefficients, the numbers in the recipe. So I have 2 cups of flour, and the equivalent in waffles is 4 waffles. So it looks like I'm converting from 2 cups of flour to 4 waffles, right? So 5 cups of flour gives me how many waffles? So if you keep going on this dimensional analysis, you're going to see that cups of flour cancel out with cups of flour. Those are units, and the result is going to be waffles. Okay, waffles. So now you just multiply all the numbers in the top. So 5 times 4, that's 20, and divided by 2, that should be 10 waffles. So what this means is that with 5 cups of flour, if you follow out this recipe, you are going to make 10 waffles, right? 2 cups of flour make 4, 5 cups of flour make 10. It makes sense, it's the same ratio, okay? So let's go ahead and do the, excuse me, the second example. That's going to be with eggs. So I'm going to take 9 eggs, right? 9 eggs make how many pancakes? 9 eggs, that's an extra G that I have in there, okay? Excuse my grammar errors. So we are doing the same. We're doing a mole of A to mole of B conversion, okay? So moles of A, that's from X, we are converting to waffles. And where am I going to get these two numbers to place in the dimensional analysis? From the equation. 3x make 4 waffles. So I'm going to do 3x make 4 waffles. And I'm going to do the math. Of course, x are going to cancel out with x, and the result is going to be waffles. So let's see how many waffles I can make with 9x, assuming I have enough of everything else, right? Assuming I have enough. So you got to multiply the tops and then divide by 3. So 9 times 4, that's 36 divided by 3. That should be 12 waffles. So it looks like I have enough eggs to make 12 waffles. Okay, that's the second example and the second part of the exercise. And now let's take 3 teaspoons of oil and see how many waffles I can make with that. Okay, so 3 teaspoons of oil. We're going to do the dimensional analysis. Okay, so teaspoons of oil go in the bottom so they cancel out, and waffles go on top. Excuse me. And where am I going to get the numbers that go in here? From the chemical equation again. So 1 teaspoon of oil makes 4 waffles. Okay, so 1 teaspoon of oil makes 4 waffles. And then I'm going to do the math. Of course, teaspoons of oil and teaspoons of oil are going to cancel out. The resulting unit is going to be waffles. Waffles, and you do the math. So 3 times 4, that's 12, divided by 1, that's 12. So now you have to make a decision. Right? What is your limiting reagent or your limiting reactant? Which of these guys is going to run out first? So it looks like I have enough flour to make 10 waffles, enough eggs to make 12 waffles, and enough oil to make 12 waffles. So can you see that if you mix these ingredients, let's assume you're going to mix all of these ingredients, right? When you mix the 5th cup of flour, when you put the 5th cup of flour, you're going to make 10 waffles, and you're not going to have any more cups of flour to keep going, right? So this is going to run out first, because when you make 10 waffles, you're not going to have any more flour, right? Can I make 12 waffles? Well, I have enough eggs and I have enough oil to make 12 waffles, right? But I don't have enough flour or cups of flour to make 12 waffles. I only have enough flour to make 10 waffles, right? So that's the highest amount of waffles that I can make. There's no way that with 5 cups, 9 eggs, and 3 teaspoons of oil, I'm going to make anything greater than 10 waffles. Of course, I'm going to have some eggs left over. I'm going to have some oil left over, but I'm not going to have enough flour to make more than 10 waffles. So this is what we call the theoretical yield. Theoretical yield, which is what is the highest amount of waffles that I can make before I run out of one ingredient. So you're looking for the number that's smaller of all of this. Okay, if you convert to moles or you convert to grams, you're looking for the number that's smaller from all of this. That is your theoretical yield. And the reagent associated with the theoretical yield, this is the limiting reagent. Let me, again, excuse my grammar. Limiting reagent or reactant also. Those are two common names, right? Limiting reagent or limiting reactant. So the flour is the limiting reagent, and the theoretical yield is going to be 10 waffles. That's the highest amount of waffles that I can make. I cannot make 12, even though I have enough eggs, enough oil, but I don't have enough flour to make 12 waffles, right? So this is the number that you care about. That's your theoretical yield, which means that with all these ingredients, you're not gonna make more than 10 waffles. There's no way you can make more than 10 waffles, okay? So in the next video, I'm going to talk about the percent yield formula. So it has to do with the theoretical yield. You have to calculate a theoretical yield always. So you have to do the same exercise. You have all of the different ingredients. You will have to do a dimensional analysis for each of them and find out which is going to produce the smallest number of product, right? 10 waffles, 12 and 12. So 10 waffles is my theoretical yield and the limiting reagent. The other reagents, X and teaspoon, we're gonna call those excess reagents, which means I have a little bit of in excess, right? I'm not gonna run out of those. Those are a little bit extra in there. Okay, so those are a little bit of terms that might come in handy for the next handouts.